two. Number two is probability, which covers stats pretty much. It says the table above shows the distribution of age and gender for 25 people who entered a contest. If the contest winner will be selected at random, what is the probability that the winner will be either a female under the age of 40 or a male aged 40 or older? So this is a very simple like probability skill from statistics, and what I will tell you is that there is like a formula for it, but I'll tell you that in this case, whenever you see or, you're adding the probabilities. That's something that I learned, and it should always remain true. So when you have something like this, all you have to do is add the first probability and then add the second one. And there's another step that you would have to do if this problem was different. So if we get to something like that, I'll tell you guys how to do it. But for this one, whenever you see or, it's adding. If you see and, it's usually multiplication. So hopefully that's a good tip to know. But so really we need to find the probability that she's a female under the age of 40 and then male aged 40 or older. So let's look at the first one. A female under the age of 40. So female under the age of 40, well, out of the 25 people that are here, under 40 is 8, under 40 is 20, females here. You just find, it's kind of like you're interpolating on a chart and you're just finding which one matches. So the first one, female under the age of 40 is 8 over 25. Adding, because we have the or there, male aged 40 or older. So male aged 40 or older, this one would be 2. So this would be 2 over 25. All you have to do is add them together. You get 10 over 25. My first thought is to simplify that, but as you can see, they don't even care about that. They just have the answer there, unsimplified. So yeah, that one wasn't too bad. It's just knowing the rule that or means to add. So that's really the most important takeaway from that question. All right. And remember that if I'm going too fast, if you have any questions, just let me know and I'll be happy to explain. So let's see the next one. I'm gonna try to do, I'm trying to think about which ones are the best to do. These are not too bad, and since this section is longer, I think I'm just gonna do number 5, because that's the hardest one on this page, I would say. So it says, at Lincoln High School, approximately 7% of enrolled juniors and 5% of enrolled seniors were inducted into the National Honor Society last year. If there were 562 juniors and 602 seniors, which of the following is close to the total number of juniors and seniors at Lincoln High School last year, who were inducted into the NHS? So, all right, so this one is not too bad, of course. And another good tip is that you're going to notice that all these on this page, at least, are not going to be too hard, just because, as I've been saying for the past few sessions, they increase in difficulty as you move through the test. But this one, well, all you'd have to do to find it is multiply. You need to know that 7% and 5% can be rewritten as 0.07 and 0.05. Because that's kind of how we're going to be able to find the number of juniors and seniors within each respective group. So it says that 7% of juniors and 5% of seniors. We have 562 juniors and we have 602 seniors. So all you have to do is multiply this times 0.07 and this one times 0.05. Because when you're trying to find 7% of a certain group, which is what we're doing, you multiply the whole times the decimal component of that percent, which is 0.07 and 0.05. Now is when I would tell you guys to take out the calculator and just solve that. This is one of the many times where you definitely need to use a calculator because that will take too long to solve on paper. I get 39.34 over here. And for the other one, I get 30.1. Now it's saying how many in total. So notice how 39 and 30 are two options. Well, really what you have to do is combine them because it's saying juniors and seniors. Juniors and seniors. So when you combine them, you get around 69, and it's just an approximation, so B is the answer. So again, this is just one of the many questions that I think is very doable on this SAT test, but it's just good to do these as quickly as possible. It's okay if it takes you 5 or 10 seconds to do it, just because there's going to be a point where I find that some of the questions take 2 minutes, 3 minutes, even 4 minutes, just because I stare at them and then I'm just like, how do I do this? So try to reserve time for those and get these done quickly. All right. Yeah, at least everything else on this page is not something that we haven't seen before. So that's what I'm trying to focus on. Number 7, number 8. All right. So what I'm gonna do is I think I'm gonna do number 7 and number 9. Number 8 is an interpretation of it looks like it's an interpretation of slope, so that shouldn't be too bad because we've seen that before. So number 7, it's really just knowing how to get rid of variables and isolate them. And for this one, all you have to do is multiply by the reciprocal. And when you do that, these cancel out and you're left with 20 over 9. So let me cross that out. The answer is 20 over 9. It's that. So just know that the reciprocal is the kind of like the opposite, the flip of what you have here, and that's how you get rid of fractions. So the reciprocal of this would be 5 over 3, and that's why I multiplied by 5 over 3 on both sides. Not too bad. That's something that I think most people can do in a few seconds, so it's another one of those like freebies, I would say. All right, number 9. If Nate walks 25 meters in 13.7 seconds, it's saying Nate walks 25 meters in 13.7 seconds. If he walks at the same rate, which of the following is closest to the distance he will walk in 4 minutes? So when I see this, I want to set up a proportion because it's just whenever you see like that you have 25 meters and 13.7 seconds and you're given something else, but you're trying to find what the meters is for another time, my mind automatically goes to proportions. There's only one like little trick about this. You can't put 4 here because there's 2 different units. This is in seconds, this is in minutes. So what I would do before you do anything, before you do the proportion, is convert the 4 minutes into seconds. Remember, there are 60 seconds in a minute, so all you have to do is do 60 times 4. You can do that in your head or do it in your calculator. You should get 240. And now that everything is in the right units, now we can do the proportion. That's really important about proportions. It doesn't work unless everything is in the right units. So now it won't give you the direct answer unless everything is in the correct units. So now, of course, I can just replace this question mark with an X, which is what you guys are more familiar with when solving for an unknown. You get 13.7x is equal to, now I would do the calculator, 25 times 240. That ends up being like 6,000. You divide by 13.7 on both sides. And when you do that, you should get like 437 as your answer. Oops, 437. And there's only one answer here that's relatively close to that, and it's B. So that's the only possible answer for this question. So yeah, so what I'm gonna do now is move on to the next page, just so we can try to do as many as possible. All right, this is an interesting one. I'll do both of them, just because yeah. So it's one of the many questions you'll find on the second part of the SAT that has like one stem and then it has 2 questions that go along with it. Some of them even have 3. So yeah, let's look at it. It's a chart with the gravity in meters per second squared for all the planets in the solar system. And it says the chart above shows the acceleration due to gravity in meters per second squared. It tells you the weight, how you can find the weight of an object, which is the weight is equal to the mass times the gravity. And it's telling you weight is in newtons, math is in kilograms, g's the gravity, which is just over here. So those are really ugly arrow, but it's basically just telling you to look over here. So let's look at number 10. It says, what is the weight in newtons of an object on Mercury with a mass of 90 kilograms? Well, weight is equal to m times g. It's telling us the mass is 90 kilograms. All we have to do is find the g. The g of Mercury is 3.6. So in order to solve that, all you have to do is 90 times 3.6. So that shouldn't be too bad. When you do that in your calculator, of course, you got 324. So that's the answer, and that's the weight. Let's look at number 11. It says, an object on Earth has a weight of 150 newtons. On which planet would the same object have an approximate weight of 170 newtons? All right. So for this problem, what I would notice first is that it's giving you the weight, and since it gives you the weight, the W is equal to mg equation. We already know that the weight is 150. We don't know the mass, so that's still an m, but we know the g because it tells us right here. And if you know from science class, the g of Earth is always 9.8. So the first thing I would do is I would kind of divide and find the mass that goes along with it, because in order to find the weight of 170, you kind of need to know the mass and then kind of test every single one out to see which one gives you 170. So when you do that, when you do 150 divided by 9.8, you get something close to 15. Yeah, 15.3. So now we know the mass. Oops. Now we know the mass. And let me just erase the work from the previous one, just because that's kind of distracting. So now that we know the mass, we can go back to our equation. W is equal to mg. We know our m. We can find each g from the chart. Now we have to do see which one gives us a weight of 170. So since our mass is 15.3, all I have to do now is kind of check and see which one gives us the right one. So I'm gonna go through each planet and multiply and just see which one gives me the closest amount. So for Venus is 8.9. So do 15.3 times 8.9 in your calculator. You should get, oops, sorry about that. I think I messed up my calculation. Let me just redo that. Sorry. You should get 136.17. That's not 170. So that's out. The next one I'm gonna plug in is Saturn's. And this is one of the many times that I would say guessing and checking is the quickest way, just because it's so easy to type it in your calculator. 15.3 times Saturn, which is 11.1. I think that one might be close. Yes, you get 169.83, which is practically 170. You can stop there. Saturn is your answer, and that's it. So, yeah, this was an interesting problem because they apply a lot of different concepts from a whole bunch of subjects and find a way to put them into math. So that's really cool. All right, let's see, number 12. I'll do number 12 just because it's a good review of graphs, and I'm looking at the other ones that are here. I like all of them, so I'll do all of them. Number 12. If the function f has 5 distinct zeros, which of the following could represent the complete graph of f in the xy plane? Good thing to know about zeros of any equation or graph, it's when they hit the x-axis. So if there are 5 zeros, and it's saying there are 5 distinct zeros, so that means that there's 5 different places where it hits the x-axis. That's practically what it's saying. So what I would do is I'd count how many x-intercepts each one has, and that's how we find the answer. This one has 1, 2, 3, 4. Not this one. This one has 1, 2, 3, 4. Not that one. 1, 2, 3, 4, 5, 6. Not that one. D has to be the answer, but 1, 2, 3, 4, 5. Yes, that's it. So that's the easiest way to do this problem. And yeah, there may be other questions that test your knowledge of like the shape of the graph, but at least for this one, you can tell that just what it would look like just from how many zeros are there. I think that's the easiest way to solve it. Number 13, it says the equation above gives the height h in feet of a ball t seconds after it's thrown straight up with an initial speed of v per second, a whole bunch of letters pretty much. That's pretty much what that problem stem is saying. So it says, which of the following gives v in terms of h, t, and k? So all you have to do is solve for v. So let's do that on the side, just so we can get a good review of that. All right, solving for v. The equation, of course, is h is equal to negative 16t squared plus vt plus k. Those t's kind of look like pluses, but you get it. The first thing I would do is move everything that isn't a v to the other side. So h plus 16t squared minus k over v is equal to vt. Just leave the v on the other side, and then divide by t everywhere. So your answer would normally just be this, but at least in this problem, they kind of want you to simplify it even more, because you can, if you look closely, you'll see that the ones that kind of resemble this, A and B, are not the answers. So they don't look like what we have there. So what we have to do now is we divide and kind of see, we have to simplify it pretty much. So what I noticed is that in both of these answers, what they did is that they took the t squared over here. They noticed that there was a t on the denominator, and they just canceled them out. But that's the only term that has a t in it. So it's the only term that can be kind of canceled. Everything else has to solve the t over it because there's nothing to divide it by. So going back to this, when you end up simplifying this, you should get h minus k over t. And then I think it ends up being plus 16t. So it has to be that. You could kind of tell just because it's a plus right here. So the plus is going to stay the same, and that's going to be your answer. So yeah, that's how you do that problem. And let's look at number 14. All right. So it says the cost of using a telephone in a hotel meeting room is 20 cents per minute. Which of the following equations represents the total cost, C, in dollars, for H hours of phone use? All right. So this one. So I will tell you that when I first saw this problem, I was kind of confused. But and the way I kind of checked my answer and found it was using my calculator. So again, it shouldn't be too bad, because now that you look at it, it's clear that since it's 20 cents per minute, and there's 60 hours, 60 minutes in 1 hour, all you have to do is multiply this by 60 to figure out how many cents or how much it costs per 1 hour. But there's many ways to do it, and I'll tell you guys how I found the answer, even though I didn't kind of understand how to set it up at first. So what I did was I kind of found how much it would be using the problem stem. So let's say that what I did was I multiplied 0.20 times 60, because it's saying it's 20 cents per minute. And when you multiply 0.20 times 60, you get how much it's worth for 1 hour. There's 60 minutes in an hour, right? You get that it's $12. So now, in order to kind of just check your answer, you just have to plug in 1 into all of these, because now that we've changed the units to hours, whichever one gives us $12 for 1 hour will be our answer. And when you plug them in to everything, A is what you get. If you plug in 1 over here, you get 60.2, which is wrong. This is also wrong. This is also wrong. And it kind of just relates to what I just did with the 60 times 20. It's literally the same exact thing. So that's really how you do that one. If you're unsure, but of course, the logic behind choice A is that if you do 60 times 0.20, you get how many minutes, or how much it would cost for 60 minutes, 1 hour. That's the gist of it. So let's look at the next page. All right. I like number 15 because number 15 is a stats question. All right. So let's look at it. It says, in order to with these questions, I will say pay very, very close attention to the stem of the problem. There's a lot of these answers look the same, but there's like 1 or 2 words off from each choice, and that's what kind of trips everyone up, just because there's always something in the problem that kind of gives you the right to choose a certain answer with these. So it says, in order to determine if treatment X is successful in improving eyesight, a research study was conducted. From a large population of people with poor eyesight, 300 participants were selected at random. Half of the participants were randomly assigned to receive treatment X, and the other half did not receive treatment X. So 150 went to the other 150 went to the other group. The resulting data showed that participants who received treatment X had significantly improved eyesight as compared to those who did not receive treatment X. Based on the design and the results of the study, which of the following is an appropriate conclusion? All right. So the first thing that I will tell you, and this is probably the most important thing, is that we took a sample from people with poor eyesight. So the results of this study can only be applied to people with poor eyesight. So that's how you get choice A, because that's the only one that tells you the eyesight of people who have poor eyesight. This one says anyone who takes it. We only know results from people who took it with poor eyesight, so that can't be assumed. B says improve the eyesight better than all available treatments. In order to make that conclusion, even to get to that conclusion, you'd have to have another treatment option, and it was only treatment X, so it can't be that one either. And treatment X will cause us substantial improvement in eyesight. Cause is a very strong word, I would say, and even though we're doing an experiment, no, we're not even doing it. Well, we are doing an experiment actually. This is an experiment, but it's just too like absolute. And it doesn't specify if we're to say like, oh, it'll cause a substantial improvement in eyesight for people who have poor eyesight, I would be more inclined to look at it. But it kind of just assumes that it would cause the improvement for anyone. That's what's kind of implied there. So I'm not liking that one either. A is the best because it specifically mentions the group that we sampled from, and it's not as like strong or absolute, and that's really an important thing about the SAT. Do not pick an answer that is so absolute that it's probably not true. Let's look at number 16. All right, so graphs of the functions f and g are shown in the xy plane above. For which of the following values x does f of x plus g of x equal 0? Well, I know that like when you're looking at this graph, you may be inclined to like think of these 2 points over here, but you have to think of f of x plus g of x. You have to think of a value that they're going to be on the same x value. When you add the one on the top and the one on the bottom, they're going to be 0. There's only one obvious one over here, and I see this one, 2 and -2. That's 2, that's -2. When you add them together, you get 0, and I notice that that is at -2. X is equal to -2. So B has to be the answer because that's the only place where the function on the top and the function on the bottom add to 0. Well, there's maybe another place, but at least out of the choices that were given. So yeah, that's how you do that problem. And remember to stop me if things are not making sense. All right. So for this one, I'm looking at it. I think that number 17 and 18 are not too bad, just because it just looks like it's linear equations. All right. What I'll do is I'll skip this page just because I really do like to get to the long responses. We still have a few more to go till we get there. All right. So, I'm sorry. I really do want to pick the best ones to do. All right. So what I'll do is I'll do number 20 because that's also a stats related question. Number 20 and 21. So let's see. It says Michael swam 2,000 yards on each of 18 days. The scatter plot above shows a swim time for and corresponding heart rate for each after swim. Sorry about that. I kind of messed up that sentence. The line of best fit for the data is also shown for the swim that took 34 minutes. Michael's actual heart rate was about how many beats per minute less than the rate predicted by the line of best fit. So important thing to know about scatter plots, the actual values are the points. The line is your predicted value. The line is kind of just like an estimate of where it would lie if it was like an average of everything. So for 34 minutes, it's like right over here. I see that the actual one is over here. It's over there, and then the line is over here. I'm looking at this graph, and I could tell that the predicted one is 150, right? And it looks like this is increasing by 2. So 2, 4, 6, 8. Yeah. So it looks like his actual thing was 148 because it's only one block lower than the predicted. So the difference is 2, and that's how you get that. So number 21. Of the following four, oh, I guess that it's not a two-part question, but I guess I'll do 21 too because it's also a good test of like exponential growth and things like that. So of the following four types of saving account plans, which option would yield exponential growth of money in the account? So really you just have to kind of think about it and which one won't be linear, and it should be pretty obvious when you look at all of them. So let's look at choice A. Each successive year, 2% of the initial savings is added to the value of the account. Well, if we're only adding 2% of the initial savings, it's going to be the same every year. It's going to be the same growth because the initial savings could be 100 and they just be adding 2 every year. So it can't be that one. Each successive year, 1.5 of the initial savings and $100 is added to the value of the account. Same thing, it would just be like $1.5 every year, $1.50. And then of course, adding $100 each year is not linear. It's just adding the same amount. I mean, it is linear, so it can't be exponential. That one would also not be good. Let's look at choice C. Each successive year, 1% of the current value is added to the value of the account. Well, if the current value is 100, you add 1%, it becomes 101. And then they add it every year. So now if your new value is 101, you take 1% of that. It would just be kind of slightly bigger than $1. So now it would be like 102.1, for example. So it is exponentially growing because you're adding more and more each year. So this is the answer to that problem. And let's look at choice D. Each successive year, $100 added to the value of the account. No, that's just increasing by 100 each year. Not that one. So C is the answer to this. And yeah, I'm just gonna go ahead and move to the next problem, just so we can get those long response ones. Number 25 is like a question on the volume. So yeah, the last one that I'll do here in this section for today is number 23. This because it tests an important concept that I've noticed appear several times so far in the SAT tests that we've done together. So let's look at that one. It says the angles shown above are acute, and so that means that they're less than 90. And it says that sine of A is equal to cosine of B. If A is equal to 4K minus 22 and B is equal to 6K minus 13, what is the value of K? So an important thing, this goes back to a rule that I kind of talked to you guys about. In order for the sine of A to be equal to the cosine of B, A and B have to add up to 90. And that's kind of our method of solving this problem. So this just goes back to right triangle trigonometry. When we're doing it, this can be side A, B, C. Let's say the sine of this one, we'll put capital letters. So the sine of B would be A, or remember it's SAGATOA. It's an important acronym from geometry that will really help you out on the SAT, of course. So the sine of B is opposite over hypotenuse, so that would be A over C. Well, let's try the cosine of A, because it's telling us that the opposite one will give us the same one. Cosine of A is adjacent over hypotenuse, A over C. They're the same thing. So that's kind of how that works. Since 90 degrees of our 180-degree triangle is kind of reserved for this section over here, we know that everything else has to be 90, and that's why we get that A and B have to add up to 90. So we know that A's the value of A is 4K minus 22, and the other one is 6K minus 13. Well, we know that A and B together have to be 90. So what we can do is we can actually just add these two together, the letters it gave us, and make them equal to 90. And then from there we can solve and get what K is equal to. Let me just erase that. When you do that, all you have to do is combine like terms. This ends up being 10K. This is a 35 over here. You can move the 35 over to the other side. That ends up being like 125 over 10K. You divide by 10 on both sides. You don't need a calculator for that. It's 12.5. So that's the answer. And yeah, that's the best way to do that problem. It's an important concept because I've seen it several times and it could very well show up on our SAT. on August 29th. So now that we know how to do it, hopefully when we get a problem like this, you guys all get it right. All right. So yeah, there are of course a few more multiple choice to do, but I do want to get to the written responses because those you can't really guess on. You have to kind of know what you're doing. So let's think. All right. So it says, let's look at 31. It says tickets for a school talent show cost $2 for students and $3 for adults. If Chris spends at least $11 but no more than $14 on X student tickets and one adult ticket, what is one possible value of X? All right. So in order to find the total cost of these tickets combinations, it would be 2S plus 3A, because the amount of tickets the students buy are $2 each, and the amount that the adults buy are $3 each. In order to figure out the cost that he spent, we can already kind of plug in A, because it tells us that he bought one adult ticket. So let me just plug in one over here. That's already something we can know. So the total cost that he spent has to be 2S plus 3, some value of S. And we also know that 2S plus 3 has to be greater than or equal to 11, because it says he spent at least $11. But 2S plus 3 also has to be less than or equal to 14, because it says that he didn't spend more than 14. So now all you have to do is solve kind of for each. Let me just draw a line here and move this one to the other side, just because it wasn't smart of me to write them like that. So 2S plus 3 is less than or equal to 14. All you have to do is move the 3 to the other side. This becomes an 8. Divide by 2. So S has to be greater than or equal to 4. So that's one important fact of this problem. The next one, this becomes an 11. 2S divided by 2. S has to be less than or equal to 5.5. And I'm running out of space, so I'll write it over here. That's another important fact. So these are like the constraints of our problem. We know that the amount of tickets that for the students could be greater than or equal to 4, or it could be less than or equal to 5. So in actuality, since you can't buy half a ticket, there are only 2 possible answers. You can say that he bought 4 tickets or that he bought 5 tickets. And that's the answer to this problem. It's either or. Both of them meet the requirements that we just figured out. And yeah. So the next one that I want to do is, I'll do number 30. I'm just trying to look at the best problems. I'm going to do number 33 and then 34. So number 32 is just figuring out the average of all those ages. You guys know the average is adding up all the ages and dividing it by the amount of people that are there. And it just tells us that it's 12, so we already know that. So let's look at number 33. It says, if the expression above is rewritten in the form of the traditional polynomial form, x squared plus bx plus c, where a, b, and c are constants, what is the value of b? So for this problem, all you have to do is just simplify it and combine like terms and figure out what your b value would be. So for this, sorry about that. Of course, the negative 3x squared plus 5x minus 2, you don't have to do anything to that. It's kind of already there. But there is a negative 2 in front of this, so you do have to simplify that. So this ends up, if I distribute it to each term, you get negative 2x squared plus 4x plus 2. Now all you have to do is combine like terms. You end up getting these can combine, these can combine, and these can combine. So this becomes negative 5x squared plus 9x, and that's just a 0, so I'm not going to write anything. Well, yeah, you can write 0 if that's easier for you to see. When you compare it to the equation over here, the b matches up with the 9, so b is equal to 9, and that's how you solve that problem. All right, let's look at number 34. In a circle with center O, central angle AOB has a measure of 5 pi over 4 radians. The area of the sector formed by central AOB is what fraction of the area of the circle? All right. So, the one thing I will tell you about this problem is that it shouldn't be too hard to find, only because with this I'll kind of draw it out and show you guys what the central angle looks like just as a review. The center is O, and it's telling us that whatever arc is made by that AOB, this is the central angle. That's what it would look like. And it's telling us that this arc over here is equal to 5 pi over 4. So in order to find the fraction of the area of the circle, you just kind of have to think about how big the circle really is. It's a very common fact that a full circle, the unit circle, is equal to 2 pi radians. It's telling us that the given arc length or given area that is there is 5 pi over 4. So from this idea, we can kind of figure out what fraction it is, because if we know that it's 5 pi over 4 radians, and we know that the whole thing is 2 pi, all we have to do is reduce this, and it'll give us how big it is in terms of the whole circle. So this can be rewritten as 5 pi over 4 times 1 over 2 pi. You just keep change flip, of course. The pi's cancel out, and you should get 5 over 8. That's how big it is in terms of the entire circle. So this measurement over here is 5 over 8. It's 5/8 of the entire circle. It's just really knowing that common fact. Don't get confused about the radians. And just think about what it's saying, the fraction of the area of the circle. It's also important to know that the radian measurement is kind of just, if you convert it to like degrees, maybe that would make it clear, but still, that's how you do that. All right, so the next problems. I have 3 minutes left, so I'll do number 37, just because, yeah, it's probably the only one that I can finish left, and then the rest you guys can do on your own, and if you have any questions, of course, you can ask me. So it says, in the xy plane, if a point with coordinates a comma b lies in the solution set of the system of inequalities above, what is the maximum oh my god, I can't speak. I don't know what's wrong with me today. Maximum possible value of b. So, all right, how would we do this? Okay, the first thing that I kind of think of when I see like inequalities, I kind of think about how they're a little bit different than just regular equations. And I'm gonna kind of sketch out how this would look, only because it's kind of hard to see them and how they work unless you have like a picture in front of you. Remember that when you have an inequality, I'll kind of just like sketch the line, not very good, but kind of. Negative 15x squared plus 3,000 would be like a y-intercept over here, and the line would be decreasing. Let me draw it in a different color. I'll do this one in yellow, like that. It doesn't have to be to scale or anything. It's just kind of an idea. And it's telling us that y has to be less than or equal to this. So if you remember, we kind of shade everything under here because those are our possible values. Our next equation, I'll do this one in blue. It's just 5x. So it's like a slope like this, and it's like you're shading everything over here. So it's saying that this the solution set of the system is a point a comma b, and it's telling you what is the maximum possible value of b. Well, if you're looking at this graph, it becomes really clear that the maximum possible value of b, the points where both solutions or both areas are shaded in, this is like our area that's shaded in for both. And it's like the maximum possible value for this is right over here. It's right where they intersect. So in order to find the possible value of b, what you do is you set these two equal to each other, because the point where they intersect, of course, is where they are equal to each other. Yeah, I kind of ran out of space, so let me give myself more room to solve it. So negative 15x plus 3,000 has to be equal to 5x in order for this solution to reach its maximum possible value, which is over there. And then of course you just move variables around and solve. This becomes a 3,000 and then to 10x. When you do that, you should get, I think I moved this wrong. Sorry about that. You have to move the 15 over there, yeah. You move a 15 over here. This becomes a 20x instead of its 10 that I wrote. When you divide 30,000 or 3,000 by 20, you should get 150. Remember, it's asking for the b, so all you'd really have to do is just plug it into one of the ones there, because that's our x value where it reaches the maximum value. It's not the maximum possible value of b because it's the wrong coordinate. So all you have to do is plug in 150 into one or the other. Remember, it works for both, so do whatever's easier. 5 times 150 is easier for me. You should get 750. That means that b is equal to 750. That's the maximum possible value. And I for one thought that at least drawing it out was an easier way to picture it. So hopefully that helped. I'm gonna move it over to Natalie now. So yeah, she's gonna be doing the grammar section with you guys, and I really hope that this lesson today was helpful.